In 11.2, we will be graphing linear equations in two variables. In example 1, it says complete each ordered pair for the equation. So recall from the previous section that our solutions, x and y, make an ordered pair which represents a point on the line. So for example 1, our equation is x plus 2y equals 7. And we're given the x value of -3, and we're trying to find the y value. So we'll substitute -3 for x, so that's -3 plus 2y equals 7, and then we'll solve for y, so we'll add 3 to cancel the -3, and that gives me 2y equals 10, divide by 2, so y equals 5. And on B, we have x is -1, so we'll substitute -1 in place of x, so -1 plus 2y equals 7. Add 1 to both sides, so 2y equals 8, divide by 2, and that gives us y equals 4. Okay, on C, our x value is 3, so this would be 3 plus 2y equals 7, subtract 3, so that gives me 2y equals 4, divide by 2, so y equals 2. On D, we'll substitute 5 in place of x. 5 plus 2y equals 7. Subtract 5. So 2y equals 2. Divide by 2, so y equals 1. And for E, 7 plus 2y equals 7. Subtract 7 from both sides. 7 minus 7 is 0. Divide by 2. So if I take 0 divided by 2, that's 0. So my ordered pair is 7, 0. On example 2, we have our equation, and we have a table with values, and we're going to complete the table and then graph those points on the grid. So we're going to complete the table just like we did on example 1, where you substitute in the value that you're given and you find the missing value. So for x plus y equals 6, we're going to substitute 0 for x. So 0 plus y equals 6. That means that y is equal to 6. And the next one, we're given y is 0. So if I substitute 0 for y, then I have x plus 0 equals 6, which means that x is equal to 6. And then my third point, x is 2. So that's going to give me 2 plus y equals 6. If we subtract 2 from both sides, that gives me y equals 4. Alright, so my ordered pairs are 0, 6, 6, 0, and 2, 4. So those are the points that I'm going to graph. So 0, 6, that means I have 0 on the x and then 6 up on the y-axis. Then 6, 0 means I'm going to go 6 spaces to the right on the x-axis, then 0 up and down. And then 2, 4. So over to 2 and up 4. And then I can connect those to make a straight line. Okay, and one way that you can tell that you're doing this correctly in this section, since we're dealing with linear equations, your points should line up to form a straight line. So if you always do 3 or more points, then that'll give you a good way to check that you did it correctly. Example 3 says make a table of values and graph the linear equation. So this is the same thing we did on example 2. The only difference is the table's completely blank. You get to make up what x and y values you want. Alright, so one easy way to do this is to make x equal to 0. So if I do 2/3 times x, 2/3 times 0 is 0. So then I get y equals 0 minus 2, which is y equals negative 2. Okay, so if you start by making x 0, then that's always one easy way to get your first point. Okay, now the next ones, since this is a fraction 2/3, I want x to be a multiple of 3, a multiple of the denominator, to kind of cancel the fraction and make it easier. So let's make x be equal to 3. And then we'll do another one where it's equal to 6. So I have 2/3 times 3 over 1 equals 2. So that's y equals 2 minus 2, which is 0. Okay, and then actually I put the last one as 6, but you don't even have to. You could do a negative if you wanted to. So we could do negative 3. So if I did negative 3, then that gives me 2/3 times negative 3 over 1, which is negative 2. So y equals negative 2 minus 2, which is negative 4. Okay, now had I decided to keep a 6 there, I would have 2/3 times 6 over 1, which is 4. So y equals 4 minus 2 would be 2. So 6, 2 could also be a point. Okay, so it doesn't matter which points you choose, but if you have a fraction with the x, you'll want to multiply by some multiple of the denominator. Like if I had multiplied by 1, I would be having to mess with fractions and then graphing fractions. So it's easy to multiply by a multiple of the denominator to clear out your fractions. Alright, so now let's graph these. So 0, negative 2 is on the y-axis, 3, 0 on the x-axis, negative 3, negative 4, so it's over 3, down 4 spaces. And then just because I did an extra point, 6, 2, and then notice that all of them line up. perfectly. Example 4, find the intercepts for the graph of 5x plus 2y equals 10. So this word intercepts. Intercepts is where it crosses the axis. So the x-intercept is where the line crosses the x-axis. The y-intercept is where the line crosses the y-axis. So whenever you see the words find the intercepts, automatically on your table you want to put a 0 on x and a 0 on y. Okay? When x is 0, that tells you where it crosses the y-axis, so this is going to be your y-intercept. Where y is 0, that'll tell you where it hits the x-axis, and so that'll be your x-intercept. So that keyword, find the intercepts, means put a 0 on x and a 0 on y, and then you can find a third point that is whatever x or y value you want. Okay, but you have to start with those two zeros. Alright, so the nice thing about finding intercepts, it's pretty easy, because if you put a 0 in for x, 5 times 0 is 0. So you're basically blotting out that 5 because it's equal to 0. And you have 2y equals 10. So then just divide by 2, and we get y equals 5. Then for y equals 0, that means 2 times 0 is 0. So you're basically covering up your y. And you have 5x equals 10. Divide by 5. And we get x equals 2. Okay, so you can find those pretty easily, basically just by covering up the x term with your finger and looking at the rest, covering up the y term and solving the rest just as a one-step equation. Alright, and then after that, you can pick an x and a y just to have a checkpoint. Oh, I covered up part of those directions. So the directions in parentheses said, be sure to find a third point as a check. So these 2 points should give me my line. So 0, 5, and 2, 0. And then we're going to find a third point just to check it and make sure it lines up with those 2 points. Because if I just do 2 points, I'm going to have a straight line. So the third point tells me that it's the correct straight line. For 5x and 2y, I would probably pick an x value like probably 4, because if I picked 3, 5 times 3 is 15, so when I subtract it, that would give me an odd number, and I know that because I have 2y, I'm going to want to divide by 2. So I'm going to pick like 4. And it doesn't really matter. You can pick an odd number and get a fraction and graph that. It's just a little bit easier to try to make whole numbers. So if I do 5 times 4, then that gives me 20 plus 2y equals 10. So I can subtract 20 from both sides. And that gives me 2y equals negative 10, because I have 10 minus 20. Divide by 2, and y equals negative 5. So now I'm just going to graph the point 4, negative 5, and make sure that it lines up with those 2 points that I graphed. So connect those points, and that's the graph. The line 5x plus 2y equals 10. Example 5, graph 2x minus y equals 0. So it doesn't say that you have to graph by the intercepts, but I usually like to at least start with my intercepts. So if I put 0 for x, then that means that 2x is 0, so I have negative y equals 0. So if I divide by negative 1, then I get y equals 0. Alright, so now if I make y equal to 0, 2x minus 0 is 0, so when I divide by 2, I get 0 again. So notice that when this is equal to 0, when I plug in my zeros for x and y, I'm only going to get 1 point. I'm going to get the ordered pair 0, 0. So in this case, I have to find another point, because right now I don't have a line, I just have 1 point. I don't have a second to connect it with. So let's see, I can pick any point that I want, so I'll pick 5 for x. So 2 times 5 is 10, minus y equals 0. Subtract 10 from both sides. Negative y equals negative 10. Divide by negative 1. So y equals positive 10. So I'll go 5, 10. So this is my line. And it wouldn't be a bad idea for me to go ahead and just try another point in between and make sure that it lines up also. So let's say I picked 3. So that's going to be 2 times 3 minus y equals 0. 6 minus y equals 0. If I subtract 6 from both sides, negative y equals negative 6. So divide by 1 gives me y equals positive 6. So I can also graph the point 3, 6. Which also falls on the line. Okay, so that third point was just a check for me. Notice on example 6, it says graph y equals negative 5. So I don't have any x values to plug in. So let's just pick the x values, negative 2, 0, positive 2. Well, there's nothing to plug in. When it says y equals negative 5, that means y is always equal to negative 5, no matter what. So I'm going to graph negative 2, negative 5, 0, negative 5, 2, negative 5. Okay, so if you only have one variable, your line is not going to slant at all. In this case, it's going to cross the y-axis at negative 5. The y value is always going to be at negative 5. Okay, so remember, if it's y equals some constant k, you have a horizontal line. Example 7, this one's the opposite. We have an x variable, but we don't have a y variable. So if I get x by itself, so I'll subtract 4 from each side. This gives me x equals 2. So I can choose any y values I want. So let's see, negative 3, 0, positive 3. Well, there's nothing to plug in for the y, and my equation is saying x is 2. Regardless of anything, x is 2. So when I graph this, I have 2, negative 3, 2, 0, and 2, 3. So in this case, when my graph looks like x equals some constant, that's always going to be a vertical line that goes through that value that's in the equation, in this case 2. Remember, this is when it only has an x in the equation without a y. Example 8, match the information about the graphs in parts A through D with the linear equations in A through D. So, let's see. Alright, A, the equation x equals 5. So we just looked at that. This is where the x values are always at 5. So if I find 5 on the x-axis, there's 5 on the x-axis, and I'm going to draw a line straight through it. That's a vertical line. So this matches with C. Then B, 2x minus 5y equals 8. Well, I know that's not a horizontal line because I have an x and a y, so it's going to slant somewhere. So let's look at B and D. It's not going to pass through the origin because this is not equal to 0. So let's try D and see if it passes through 9 too. So if I plug in a 9 and I plug in a 2, 2 times 9 is 18, minus 5 times 2 is 10, that gives me 8. So B matches to this statement D, the graph of the equation passes through 9, 2. Y minus 2 equals 3. Adding 2 to both sides, this is the same thing as the equation y equals 5. So if I were to find 5 on the y-axis, I would draw a line straight through that. That's going to be a horizontal line. So that's A. And then D, this line is going to slant, and it's going to go through 0, 0. So through the origin, which is statement B. Example 9 asks us to use the graph and then the equation y equals 38.7x plus 450 to approximate credit card debt in 1997. Alright, so let's look at the graph first. We are looking for credit card debt in 1997. Well, this came from the example in your book, not on the margin but on the main part of the pages. And if you read through the example, it says x equals 0 represents the year 1995. So that means that 0 is 1995. So year 1 is 1996, 97, 98, 99, 2000, 2001, 2002, 2003. Alright, so they're wanting us to look at credit card debt in 97, so 95, 96, 97. So if I go up to year 2, till it hits the line and go over, that's going to be about $525 billion. Okay, so now if we use the equation, that should give us a very close, if not exactly the same answer that we get from the graph. So using the equation, 38.7 times x, which is 2, plus 450. So 38.7 times 2 is 14, 17, 77.4 plus 450 gives us $527.4 billion. Okay, so that's very close to the answer that we got by looking at the graph. And of course, we were approximating it looking at the graph, and the equation gives us a more exact answer.